Common logic errors, generally speaking, may be related to something that is derived from using bad formula. Basically, there are lots of ways to misplace arithmetic computations, arithmetic operators, such as plus, minus, divide, multiply, incorrectly use parentheses to group the results of computation, and also based on the fact that equal sign is an assignment and double equal sign is a comparison operator for equality. Sometimes we can misuse these. It's a simple typo situation. And also with strings, we should not use double equal sign to compare strings. Instead, we need to use the equals method or equals ignore case. So all of these are examples of common logic errors. As we begin to observe different type of exceptions like this, that we've been able to identify and handle, you will soon learn that there's a hierarchy of these exceptions. You can actually add your own exception classes into your code, but of course we will study these types of examples when we learn how to write our own classes in Java. Exception stack trace. We've seen an example of exception stack trace that was generated by our program, and if you'd like to access exception stack trace, essentially a trace of methods that were invoked to get to a specific exception, you can use this printStackTrace. There is a number of methods that are capable of showing you the actual stack trace preserved by the exception handler. So when we, for example, execute this program and we invoke string to integer conversion, right? So from here we're invoking this method, string to integer, and if the string does not contain, if the string that we pass to this method does not contain a good format for an integer that can be successfully parsed, again, Parseint is part of the implementation of the integer class. So somewhere in this class, when we make a call, it detects that the format is incorrect. So then an exception object is generated. We already know that this is a number format exception, and what we do inside our method is that we immediately try and catch, right? So as soon as we detect that this object is generated, we immediately check it here, we catch it, and therefore when we if we want to print stack trace right here from this exception object, of course we will be able to see that we have our main method on the stack, then there is a string to integer part of the validator, and then there's Parseint on the stack. So this will be like number 1, number 2, okay, and number 3. At least these 3 method calls are shown in this stack trace if we attempted to do the same thing, the same line in here. So we can print this for debugging purposes while you're debugging your application. So stack trace simply indicates a sequence of method calls. So from here, so Java Virtual Machine makes a call into main makes call into string to integer, string to integer makes call into Parseint. Parseint generates this exception object when the format of the string is bad, and this exception reference gives you access to this box, and this box has methods such as printStackTrace, so you can display all of this chain of calls if you want to print the stack trace. So some methods in library classes generate exceptions. the scanner next int will generate input mismatch exception if we attempt to use it and the user provides a bad format for the integer. Let's do some demonstration of these types of exceptions when we program with the scanner. So let's perhaps add another method, which would be quite useful method to our validator, that will allow us to use the same format. So we'll just kind of duplicate the same logic, but this time we are going to say get integer based on the prompt. Okay, so we'll try to program a method very similar to getString, but we will try to program getInt, which will return an integer. Okay, and we will try to prevent any kind of input validation issues internally inside this getInt method.